Let's have a look at and talk about congruent figures. Okay, so when I use the word congruent, well, what exactly does that mean? Well, I guess simply you could say that congruent figures are identical. They are the same shape and the same size. So here's a quick example. If I had these two little triangles, I've got triangle ABC and triangle LMN. Well, mathematically I could write it like this. Triangle ABC, and this little symbol means is congruent to triangle LMN. Okay, all right, that seems to be easy enough. So if I've got these stars, well, which ones are congruent? Well, obviously it's not these ones because they're not identical. They're not exactly the same size. These ones, they are congruent because they are the same size. Even though they're not in the same orientation, like that one's been rotated, it's still exactly the same. So congruent figures then can be the result of a couple of different things. The first one being a reflection. So now we know about this because we've looked in a mirror before. So if we have an object that is in front of a mirror, that little yellow line here is my mirror, well, I'm going to end up with the arrow that points in this direction, and then in the mirror reflection the arrow seems to be pointing in the other direction. So that doesn't really matter, the direction, it's still congruent. Same as if we rotate that little arrow, right? Whatever degrees we're rotating it through, doesn't matter. We have rotated that shape, but it's still exactly the same. Same size, same shape. One last one. So, oh, by the way, keep your track, we've got reflections, rotations, and the last one is this idea of translations. So now when we're talking about translations, what we're really talking about is moving this shape in the world somehow. Now the way we normally track that is by looking at the change in terms of a point. So if we look at this point here, well, we've moved it up 3 units and we've moved it across 3 units. Okay, so you can see that this point right here has been moved to this point right here. And if we were to measure the other points, like if we were to grab a different point and measure, say, this point here to that point there, it would be exactly the same. It would still be 3 units up and 3 units right. Okay, so that's translations. So reflections, rotations, and translations. That's how we end up with congruent figures. So let's have a look at the tests that we use for triangles to determine congruency, because that's what's important. Now I didn't redraw these, I just took them from somewhere else because, yeah, whatever. I was lazy. So we've got a triangle. Now this triangle will be congruent if the sides of the triangle, there's 1 dash there, 1 there, 2 dashes there, 2 there, 3 there, 3 there. So we can say that these 2 triangles are congruent because the 3 sides are equal. So now when we would refer to this in some proof or something, we would say that it is side, 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 SSS. Okay, now there's another one, angle, side, angle. Now what's actually is important with this one is we've got 2 angles and the included side. Okay, now if that is the same in 2 triangles, then we are dealing with congruent triangles, and the rule is angle, side, angle. Okay, next one, we've got our SAS, side, angle, side. So the 2 sides, and you have to have the angle that's between those 2 sides for this to work, and you would need to be able to see that that's the same in both of your triangles, and then we would have congruent triangles. Okay, side, angle, side. And the last one, it is RHS, right angle, which we have, the hypotenuse, which is always the side opposite the right angle, and just one side. So if we have those three things and they're the same in two of our triangles, then we can say that they are congruent. Okay, that's all good and well. They're our tests for congruency for triangles. What's important though is how do we use it? So let's have a look at a worked example. This one I did actually write out. So we are given in a figure that triangle ABD is congruent to triangle CBD. Okay, so let's have a look at the figure. And I've got some working out here already, but focus on the figure over here. We are told that ABD, that triangle, is congruent to CBD, that triangle there. Now, what we're asked to do is find the values of these pronumerals, of the things that we don't know. So I've started with this one down here of x, and I've said that triangle ABD is congruent to CBD. That means that the length AD is equal to the length CD. Now, AD is x and CD is 3, so therefore x is equal to 3 centimetres. Well, that's pretty simple and easy. That's the first part, right? All right, well, let's work out the angle for y, which is this angle over here. What will this one be? Well, we know that given that the triangles are congruent, that angle A, which is this angle here, is equal to angle C. Angle A is 40 degrees, angle C is y, so y is equal to 40 degrees. Oh, hang on, I got a phone call. Next thing that we want to do is we want to find the other missing bit. So this one here, once again, it's the same idea. We've got this angle BDA, which you probably can't see all of anymore, but that's okay. We can say that it is equal to BDC, which is this one. We know that that's Z, this one's 90, so therefore the Z is equal to 90 degrees. Okay, so that's a really easy example of using these ideas. This next one is a little bit more along the lines of a trickier one that you need to actually write the right thing down. Like, as soon as you see this word that's coming up right now, prove, as soon as you have to prove something, then you're going to have to need those rules, those congruency rules, because that's the stuff that you need to use to prove this. So we have a shape here. Now, I haven't set this up so that we can see the shape. Let me just really quickly, rough and dirty kind of way, see if I can make this so that I can show you the picture without giving it away. Okay, here's it. Good as I can get. So there is my shape. Okay, that's my shape, and I'm trying to prove that triangle PQS, this one over here, is congruent to triangle RQS. All right, so how do I prove? Now that's the key thing. You have to prove it. You can't just say, well, it is because it looks like it and it's obvious. All right, so let's see. We've got, first step is you need to really spell out the things that you've got. So we can say that QP, this line, is equal to QR. And the reason why I can say that, it is given. Now, what does that mean? It's given. Well, on the diagram, you can see that this has got two little lines and this one's got two little lines. When that is on a diagram, that is telling you that they are exactly the same length. So it is given in the diagram. Right, so that also means then that PS down here and RS are also the same length, and that is also given. The next line is QS, and QS is shared between both triangles. So we can say that QS is common. It is common to both of those triangles. So if we think about it, here we've got a side that is the same, and a side that is the same, and a side that is the same. So we can say that those two triangles are congruent, for the reason being, and this is really important, you have to say the reason. And the reason here is side, side, side. Okay, so I don't think I've got any others drawn up. So that is an example of how you do a proof to prove something using those congruency rules that I just showed you.